What is the difference between machine learning and artificial intelligence? Which machine learning applications are gaining traction globally? And what are some of the latest innovations in machine learning research? Stay tuned as we answer these questions on the Zista Podcast. Welcome to the Zista Podcast, where we invite senior academicians and industry leaders to answer questions that students have within a specific subject area. Today, we're going to be focusing on machine learning, and joining me today, Dr. Ha. She's a lecturer at Computer Science and Information Technology at RMIT University School of Science. Her research interests include trustworthy machine learning, automated machine learning, and data-driven software engineering. Thank you for joining us on the show, Dr. Ha.
Nice to meet you, Amit. I'm honored to have to be invited into the podcast to talk with you about the topic of machine learning and artificial intelligence.
Awesome. So I see, you're really qualified in the subject. You've completed your BSc from Portland State University. You went on to do a PhD at the University of Newcastle in Australia. And a lot of your papers on machine learning have been published in industry and scientific journals. So that really makes you a subject matter expert. And I must say, we're delighted that you're joining us today. So I'd like to jump straight into it and ask you, what really is the difference between machine learning and AI? How are they related and how are they distinct?
Okay. So first I will talk a little bit about AI, which is artificial intelligence. So basically, artificial intelligence refers to the capability of a machine or a system that can actually mimic human cognitive function like learning or problem solving. And from there, the machine or the system can actually perform the task that require human intelligence. So that's it about artificial intelligence. On the other hand, machine learning is a subset of artificial intelligence.
Right.
So basically, machine learning involved in developing new algorithm or model that can actually learn from the data and then make the decision based on the data without explicitly programming. So you can use a machine learning model in order to make prediction or to make the decision for your particular problem. So in general, machine learning is an approach in order to achieve artificial intelligence. And like you will see that in many nowadays AI-based applications, the main components will be like machine learning algorithm or machine learning model. So that's the similarity and the differences between machine learning and artificial intelligence.
I like the way you explain that in a very simple way. So really, it's a subset of AI, and it's got the capability to help you make decisions. It's a way of applying AI, creating models, advanced algorithms which help you to make those decisions. And I think that really makes sense now, because that's why you call it machine learning, because you're using an algorithm and certain data points to really arrive at a decision, right? So my next question really is, what are some of the applications that you're seeing in the field of machine learning that are actually gaining traction globally?
So nowadays, I feel like there are a lot of hype about machine learning and artificial intelligence. So I guess you must already heard about ChatGPT to interact with the user and then give advice, etc. So actually, the developer of ChatGPT is based on a lot of new innovation in machine learning research. So basically, it's on natural language processing. So basically, natural language processing is the field of develop a new method in order to understand, interpret, and generate human language. So you can use technique in natural language processing in order to develop virtual assistant, chatbots like ChatGPT, or you can develop system in order to translate language. For example, you can translate language from English to French or English to Vietnamese, etc. So those are the application of a natural language processing that got a lot of attention nowadays. But not just natural language processing, there are also a lot of other applications of machine learning nowadays that got a lot of attention from the public. For example, in computer vision. So people can use computer vision technique in order to retrieve or extract information from image or video So you can use it in order to detect object in a particular image. So let's say when you use Facebook, when you publish or post an image on Facebook, it automatically detects who in the picture, right? You or your friend, or if there is human, or if there is tree, etc. So those are also like the tend to the development of new technique in computer vision. So not just like natural language processing or computer vision. Nowadays, people also use machine learning application in many fields like recommender system, where you actually like get personalized recommendation for you. So for example, when you get to YouTube, it automatically recommend the video that you want to like, right? Or for example, when you log into an e-commerce website, that it might like automatically like recommend the product that you are highly likely to buy, right? So those also like application of machine learning. It might not really as hot as like other application in natural language processing, but it has been used for a while, and it actually affect your everyday activity. So also there are other applications in other more serious fields, like for example in healthcare and medical provider. So for example, nowadays people use machine learning in order to assist doctor in like medical diagnosis, or for example into detect any abnormality, or for example detect any like disease outcome, or for example it can be used in like financial service in order to make this assessment or like credit scoring, detect any fraud or etc. So nowadays there has been a lot of application of machine learning, and had actually like been applied to everyday activity. So you might heard about some, but actually underline there are a lot of other applications that actually affect your everyday activity.
Absolutely. And I can relate to what you're saying, Dr. Ha. I think in that sense, a lot of consumers out there would have seen machine learning in action. So you log into your Netflix, and Netflix is automatically recommending what kind of movies or shows you might like to watch next. Same with e-commerce engines, chatbots with natural language processing. It's really interesting to hear about some of the applications you mentioned in the field of medicine and finance. And in fact, at Zista, we have one division which focuses on digital marketing, right? Zista Digital.
Yeah.
And I realized this really early on, that when we publish an ad, we see that the decision to approve or reject the ad is actually taken by an AI engine, right? So they would be using the machine learning algorithms to understand whether a certain ad is appropriate or whether it needs some tweaking. So yes, I can definitely say that even as an everyday consumer, I've interacted with machine learning without even realizing that it's actually at play.
Actually, I think every of us must at some point already use application of machine learning. It's just sometimes we do not really aware about it.
Right, right, right. Thank you for that. So it's really transforming the way we interact with technology, and I think you did a good job in explaining how these applications are seeping into our everyday lives. I wanted to ask you, Dr. Ha, if you're a student who's approaching a machine learning project, how do you go about it? Could you maybe talk us through, what steps are involved in defining a problem, in collecting that data, using that data to train the algorithm, and then finally deploying a solution? Can you walk us through that process?
Okay, sure, definitely. So basically, when we talk about developing a machine learning project, a lot of people just thinking about the step where you actually write the code for the machine learning model, and then train down the data and then get the prediction. But actually, that's only one small step within the whole picture, within the whole pipeline. So actually, when you start develop a machine learning project, there are a lot of things you have to think about. So the first step is that you have to clearly define the objective, what you want to do. So because in practice, in business, normally when you have a problem, everything is very vague. So you have to very clear on the objective. What is the outcome that you want to achieve? What is the predicted variable? What is the output that you want to achieve? And then after you are clear on the objective of your machine learning project, you will then move to the next step, which is to gather and collect the data. So you have to gather all the data that you have, and then not just the normal data, but also like the data that's relevant to solve the particular problem. And then after that, you have to to process the data, you have to clean the data, because in practice data can contain many like messy kind of data, and also like they can have anomaly, they can have missing data, etc. So you have to do a lot of you have to actually spend a lot of time in like process the data and then gather the relevant data for your machine learning project. And after you already have the data, you need to also do some like exploratory analysis in order to understand the relation between the data that you have. You have many types of data, so you can see like how they are associated with each other, how they are related to each other, etc. And then after that, you will need to perform some feature engineering and selection. Basically, you need to choose what type of data wanna be like impactful for your machine learning project. In fact, you have many types of data, so you need to very smart in choosing what type of data to be applied for your machine learning model. So on those steps, after you have done on those steps, then you can now move on the step where you can actually like write the code for the model using some Python package or some like popular machine learning framework out there, and then like make prediction on the data, and then evaluate to see if the machine learning model perform well on your evaluation data. And then after that, you move on to like evaluate the machine learning model with real life data, the data that you actually need to handle in practice. Because like sometimes when you train, the data that you use to train the model might not really similar to the data that actually used in practice. So you will still need to evaluate that. And sometimes, you know, if you develop a machine learning model that achieves 100% accuracy, sometimes it's actually not good for business. Because, for example, from the customer side, they will think, okay, this one it knows too much about me and I feel insecure. I don't like it.
Right.
And they just quit. So that's a lot of things like behind the scene that, okay, after you develop a model, you also need to test to see like the business metric actually like still good at before. And then after that, you began to like actually deploy the machine learning model or the system in your like actually targeted system. And then after that, you will have to like develop system for monitor it to make sure that the performance of the machine learning system actually stable as good as when you develop it. Because in practice, like you always have new data come in, and machine learning normally only perform well when the data that due to predict is similar to the data it was trained on. So you have to monitor it to make sure like the machine learning system performance also always like perform as well as when you develop it. And then you also need to like have some practice in order to maintain the machine learning system over time. For example, when you need to retrain it, and when you need to like actually perform some audit, etc. So there are a lot of steps involved in working on a particular machine learning project, where the step where you actually write the code to develop the model, like when you do it in high school or in like some tutorial on some website, it's just a small part of the whole like machine learning project.
I like the way you explain it logically, you know. So define the output, focus on what data you need, make sure that that data is clean, start building your machine learning models, use those machine learning frameworks, and then actually test and see whether it's working, see if you need to tweak it, and approach this in a very logical way. This is something that has always attracted me to the field of IT and AI and machine learning, because it's so driven by certain logics and thinking. So the more logically you think, the more thoughtfully you process as to how you want to enter that data, what data you need. It actually increases the effectiveness of the model. So I caught on to one thing when you said machine learning frameworks. So if you're a student working on a machine learning project, are there frameworks that you could pick up and use and adjust to your project?
Actually, like there are a lot of like popular machine learning or deep learning framework that published by like some big company like Facebook or Google. So basically, like I'm not sure if you already heard about it, like TensorFlow or Python, etc. So they already like develop some framework or some like model that you can like import from, and then from there you can use in order to not just develop your model, but also like, for example, how you can like debug the model, how you can monitor, observe the performance of your model. So though actually like though are a little bit like complicated, so it requires you a lot of like knowledge, specific knowledge in that particular framework. in order to make use of it, and in order to make sure that the performance of the model you develop is actually as what you expect.
Okay. And I think that helps, it's really interesting to see how the IT industry is moving in a very modular fashion. So you have these ready modules that you can plug into your solution, tweak
Yep.
it to adjust it to the outcome that you want. But
Yep.
interestingly, you don't have to start from scratch. Someone has already done that background, that base work for you. And I'm sure there's another kind of skill set that is required in creating these kind of frameworks itself. I'm sure that's
Yeah.
something will be really interesting. I wanted to
Yeah.
ask you, Dr. Ha, could you tell us a little bit about, some of the innovations that are happening in machine learning research? Are there any problems or opportunities for further advancement in this field?
Okay, so I think like recently, especially during the last half year, a lot of new innovation that happened in machine learning. So I still remember like ChatGPT was really around October or November last year, and after that, wow, the speed of like machine learning, like innovation in machine learning is like exponential. So there are a lot of new like innovation that had been going on. So first like ChatGPT, generative AI. Basically, they are related to the model that can actually like generate synthetic image or text for the user, so you can retrieve the image or the text that is very realistic, it's like human generated. So that is generative artificial intelligence, which is one of I think the biggest breakthrough in machine learning during the last like half year or so. Apart from that, there are also new machine learning or deep learning uh, architecture that actually the foundation of the generative AI model. For example, like diffusion model or like a transformer, etc. So they actually were the mathematic the math model behind the like breakthrough in generative artificial intelligence. So apart from that, there are also some new innovation like in explainability, and for example, like when we use a machine learning or deep learning model, we just know the outcome, right? We don't know why we have that particular outcome. So explainability and interpretability refer to the field where you actually develop new technique in order to guide user on why your particular model get that particular outcome. So it will give some confidence to the user regarding now know okay what's going on with the model. So that's also some like they have some new like technique and new innovation in that particular area. So there are also some other new innovation in, for example, privacy preserving machine learning. So basically, because machine learning use a lot of type of data, so people can feel worried about their privacy. So for example, that's like I use my Facebook, if I use my LinkedIn, I'm worried that my data will be recorded and then like they will use it, and that's it feel really unsafe. So nowadays, like people also develop some new technique in privacy research in machine learning, so that the machine learning model can still train from the data, but the data can be like can protect the privacy of the user. So the privacy of the user that you collect the data from are not exposed to the whole like internet or etc. So that's it also like they also achieve some new like a technique in order to ensure privacy research in machine learning. So I think also there is also another quite popular, but it's not that really have that many breakthrough though, but people are actually investing a lot on it. It's about quantum machine learning. So in machine learning, you have to train data a lot, right? You have to do a lot of computing research. So with quantum machine learning, you can actually like make your machine learning model to be trained faster. So it will
Okay.
really speed up the process of training the model, and also like in like predicting, etc. So that is also like some new. I know like for example in Australia, I heard like the government now recently invest a lot of money and budget in quantum machine learning, etc. So a lot of like I think like a lot of like innovation of machine learning is occurring, and I think like during the next one not just one few year 10 year or so, like I think like the machine learning research gonna like grow really fast.
It's really interesting, and I wanted to ask you, in we also hear this phrase called deep learning, and could you hope, if you don't mind, if you go off tangent for just a bit to understand the difference between, say, machine learning and deep learning? Could you just talk about that?
So basically, deep learning is a subfield of machine learning.
Okay.
So before I say like machine learning is a subfield of AI, right? So now
Right.
deep learning actually a subfield of machine learning. So machine learning refer to the field when you have some mathematical model that you can learn from the data, right? So in
Right.
deep learning, mathematical model that you use is actually deep. So that's why it has that name. Deep meaning that they are very complex and very comprehensive. And because they are complex and comprehensive, some people expect that they can model the data better. So that
Right.
is referred to deep learning. So deep learning is a subfield of machine learning, but the model that you use is actually deeper and more complex and more comprehensive compared to the general machine learning algorithm.
Does it need more data points for it to be effective?
Normally, yes, because the model is too big. So if you have less data point, then actually the performance will be not that good. Obviously, you can train the model, obviously, but the performance normally will be not that good. So when you use deep learning model, you actually require a lot of data compared to like the normal, simple machine learning model.
Interesting. And most of the applications that we see live today, like, say, for example, let's talk about, say, the recommendation engine on YouTube or Netflix. Is that an example of machine learning or deep learning?
Actually, it can be both.
Okay.
So, for example, like in generative AI, like ChatGPT or like Midjourney, which basically generates synthetic image, etc. So mostly like deep learning because they can learn really because they can learn really comprehensive relationship between the input and output data or the pattern of the image, etc. Because they are very complex, they are complicated. So that's mostly like deep learning. For recommended system, it really depends on the application that you develop on. So for example, if your data is simple, you only have several types of input data, then you can just simply use a machine learning model within the recommender system in order to generate the recommendation. But for example, if your data is too big, a lot of type of data from the user, for example, YouTube, it have a lot of they got a lot of like data from the user, right? So in this case, normally like they will use like deep learning model to be within the recommender system in order to make the recommendation to be more accurate.
It's so interesting, and now that you talk about it, it helps me understand it better. And I think, if a company is little new in that journey, they would maybe start with machine learning, start with a machine learning model to perform better, to help make those decisions. And as they progress in that journey, they may decide at some point to make it a little bit more complex, a little bit more intense, if I may say. And then if they have access to that many more data points, they could progress into a deep learning model to power their application. And it's so interesting. In fact,
actually,
go ahead.
it always a trade-off. It always a trade-off between machine learning and deep learning. So, for example, let's say if you just want to in business, I know a lot of company. If you just want a model that achieve, for example, 80 or 90%, and you cannot spend too much effort on it, then you just need to use a simple model, right? But for example, in the scenario where you really want to have a model that really achieve high accuracy, and you afford to spend more effort, more budget on like developing that model, then you will like move on to think about, okay, maybe like I can try some more fancy model, fancy deep learning model that can like be more comprehensive and more complex in terms of like capture the relationship of the data. So it's really your goal. I know that a lot of company nowadays, to the best of my knowledge, most of the companies still use machine learning model because they cannot afford to spend too much time on developing the model, and they only require the accuracy to be reasonable, but only in like very some particular application or scenario where you really require the accuracy to be really high, and also when your data is very comprehensive, like in image or video or text, then in that case you can use deep learning.
Yeah, in the context of what you just said, I think, medical diagnosis is a field where they would require high level of accuracy. And I'm sure they probably have a deep learning model. Another area that comes to my mind is if you're a big financial firm and you're looking at fraud highlighting fraud. You don't want to trouble the wrong customer. So you need to have a high level of accuracy to determine whether there's fraud occurring or not. And I'm sure in the field of finance also, there are a lot of deep learning models that are at play to help, companies detect fraud as it occurs. So thank you, Dr. Ha. I think that was a really nice way of you explaining it. Thank you for expanding on that subject matter. This brings me to say the last question is perhaps a very, very important one. What are the careers that students can explore in machine learning? And as a professor, as a lecturer, at RMIT University, what advice would you give them? If they want to prepare to succeed in this industry, what should they be doing?
Okay, that's a good question. So actually, I think that at the moment there are quite a lot of job positions that students can explore if they choose to pursue the field of machine learning. So, for example, to the best of my knowledge, there are some job positions like machine learning engineer, or data scientist, or research scientist, or machine learning consultant. So basically, for example, for machine learning engineer, your goal or your job, the daily job is to develop the model, okay, deploy the model in your company and like monitor it and maintain it. So everything with like developing, engineering the model in the company. So that's it for machine learning engineer. For data scientist, so mostly like you work with the data, you explore the data, you build a prediction model from the data in order to inform some business decision or to make decision, etc. So you can use the machine learning model in order to understand better the data so that you can communicate the finding with the stakeholder. So that's it for data scientist. Another job position that I just mentioned is about like research scientist. So research scientist is focused more on the research side where you actually develop new machine learning model, new machine learning algorithm, and then you publish your finding as research paper in conferences or journal, etc. So that really require very high level knowledge of understanding about machine learning or artificial intelligence in general. And finally, there also the career that I just mentioned is about machine learning consultant, where you actually consult the business to see, okay, if with this particular type of problem, you can use machine learning in order to solve it. So you will work with business, you will work with the stakeholder in order to start with a machine learning project to see the objective of the machine learning project and how you can actually begin to start a machine learning research project, machine learning project in the company. So that's the related to the role of a machine learning consultant. So actually there are, like I mentioned, currently machine learning and this is the era of big data. So a lot of companies have data, so they always want this particular role in order to help them to make use of the data that available in their company. So in talking about like how students can prepare for a career in machine learning, so there are several things that like a student need to do now. So the first thing is about the foundational knowledge. So machine learning actually is based on mathematics and statistical model, right?
Right.
So in order to know how to develop machine learning model, you will need to have like good knowledge in math, in statistics, okay?
Right.
So that later you can like understand any new machine learning model that is released. And not just like math statistics, you also need to good at programming because obviously you have to program, you have to develop the code for the machine learning model. So you have to be good at programming. So you have to know like the programming language that is normally used to develop machine learning model, for example, Python, R, and then you also need to know like some popular Python or R package that are used to develop machine learning model like TensorFlow, Python, scikit-learn, etc. So that's in the foundational knowledge. After you have the foundational knowledge, you also need to like develop your knowledge on the specific machine learning technique because nowadays there are many machine learning techniques. For example, machine technique to solve regression problem, classification problem, a generative model, etc. So you will have to learn like the machine learning technique, like from the basic one to the more advanced one. Okay.
Sure.
And then after you already acquire the knowledge in machine learning, you have to have some hands-on experience. So you have to like, for example, if you don't have access to company project, etc., you can go to website a lot of tutorial where they provide a lot of public data set and the code, etc. So you can do some hands-on experience developing some machine learning models using some tutorial on some public data set so that you have a feeling of how it is to develop a machine learning model and to see the prediction, etc. And then you can also have do some other things. For example, you stay updated to the field. For example, you follow some influencer in machine learning, some popular researcher, so that you can keep up to date with all the new innovation or the new technology in machine learning. You also need to for example, develop your soft skill in order to interact with the stakeholder, to talk to stakeholder, because in many job role of machine learning, you need to interact with the stakeholder in order to understand the data better or understand what they want to do with their machine learning project. And finally, I think one very important thing that as a student, you need to do is that you have to continue to learn. So every day, new model, new technique will be released. So it always you always need to be ready. You always need to continue to learn, to update your knowledge so that you can actually become an expert in the field. Because machine learning now really grow very, very fast. So you have to keep that mindset in order to continue the journey on machine learning.
I think you gave a very comprehensive answer, and thank you for that, Dr. Ha. So if I can just summarize, you need to have knowledge of math, statistics, and programming. You need to see what area you're interested in and follow the machine language technique in that area. Follow some influencers so they can keep up with trends and innovation. Obviously, this is a subject which is expanding and growing at a very rapid pace. So keeping track of that is really important. And, you need to really be deeply involved in this subject, I would imagine, to do well.
Hands-on experience.
Would you say, for example, students could try experimenting with smaller projects on an experimental basis just to see if the skills that they have learned or the concepts that they have understood can actually be applied? Do you think, universities today are expecting students to show projects that they have implemented before enrolling for a program, or that's something that you do once you enroll?
No. That's something you do once you enroll. So in RMIT, we have a lot of degree, for example, Master of IT, Master of Data Science, Master of AI, etc. So in RMIT, you do not need to have very comprehensive background in order to enroll in the program. No, not really. I actually teach programming in the first year for master student, and a lot of my students actually do not have any background in programming, etc. So it's not really a requirement in order to enroll in the program. But I think that to me, the thing that you need to show that you have is that your your motivation. Do you really want it? And that when you really want to pursue a career in that particular area, you will be willing to learn, right? So on the new knowledge about programming, etc., will be taught during your journey in the university, either in your bachelor degree or in master degree. But you will have to have the mindset of always keep motivated and
keep being motivated, keep learning, right? You said that's so important. Yeah. I think that's very, very true. A subject like this, an area like this, you need to keep learning, have that learning attitude. So always be a student, right? Even if you graduated and you're working in the industry, still remember you're still a student. So keep doing that.
Yeah.
Yes. Thank you, Dr. Ha. I've really enjoyed this conversation. Thank you once again for making time, to talk to us about machine learning, AI, and deep learning as a subset of machine learning. It was so interesting. I really enjoyed this discussion. So thank you for making time for this.
Okay, no worries. Thank you again for having me in the podcast. I have also really enjoyed the discussion with you. So it's a very nice experience for me.
Thank you. I hope you enjoyed this episode. Subscribe to our channel on YouTube to get more episodes like this. If you'd like to catch the audio version of our podcast, you can catch it on Google, Apple, and Spotify. Our handle is the Zista Podcast. Till we meet again, we'd say, stay curious.